Problems on bilinear transformation. So first one, find the bilinear transformation. Find the bilinear transformation which map the points which map the points z is equal to 1, I minus 1 into w is equal to I 0 minus I. Under the transformation, so find the bilinear transformation which maps the point z is equal to 1 I minus 1 into w is equal to I 0 minus I. So solution. So first we have to consider the bilinear transformation formula. The bilinear transformation is w is equal to az plus b divided by cz plus d. This is a formula what we have to find the transformation of the points from z plane to the w plane. Okay, that is we are finding the function, that function which maps the points 3 points from z plane to the 3 points in the w plane, which is the function that maps. So we should find the value of a, b, c, d. So for that we should consider the given set of points of z and w. Since here they are given 3 set of points of z and w, so I will consider 3 cases. In case 1, corresponding points only we should consider. Case 1, so put z is equal to 1 and w is equal to I. I will call this as equation number 1. Okay, put z is equal to 1, corresponding element z is 1 and w is equal to I in the equation 1. Okay, now equation 1 become w is I is equal to a into z, z is 1 plus b divided by c into z is 1 plus d. Okay, so now cross multiply, we get I into c plus d is equal to a plus b. Multiply by I and take these two terms to the RHS. So we obtain a plus b minus I into c minus I into d is equal to 0. Call it as equation number 2. So next, consider the case 2. In case 2, put z is equal to z is equal to I and w is equal to 0 in the equation 1. Here we have to consider z as I and w as 0. So therefore equation 1 become w we have to put w is equal to 0. 0 is equal to a into z plus b divided by c into z plus d. Okay, so now you cross multiply this. So we obtain 0 is equal to ai plus b, or ai plus b is equal to 0. Call it as equation number 3. Okay, so next we have to consider case 3. Next, case 3, put z is equal to minus 1 and w is equal to minus I. W is equal to minus I in the equation 1. Okay, so we obtain equation 1 become w is minus I is equal to a into minus 1 plus b divided by c into minus 1 plus d. So cross multiply. So we obtain minus I into minus c plus d is equal to minus a plus b. Now multiply by minus I and take to the RHS. So we obtain minus A plus B. It becomes plus CI. If you take to the RHS, minus I into C minus ID. Take the RHS, it becomes plus ID is equal to 0. Well, that is equation number 4. Now we have to solve equation 2, 3 and 4. So since we have 4 unknowns A, B, C, D, but we have 3 equations. So for that we have to simplify these equations to solve. So how to solve the equations? Here we have A plus B. Which two equations we should consider? Here A plus B minus IC minus ID. So here we have minus A plus B minus ID plus ID. So if we add 2 and 4, so A and D get cancelled, we will get the equation with BC, right? So and here we have an equation with AB. So two equations we will get with the 3 unknowns, we can use the Cramer's rule, okay? So now I am considering equation 2 plus equation 4. So we obtain A plus B minus IC minus ID is equal to 0. Next equation 4 is minus A plus B minus IC plus ID is equal to 0. So minus A plus A cancelled, minus ID plus ID cancelled. So we obtain 2B minus 2IC is equal to 0. Divide by 2, we obtain B minus IC. B minus IC is equal to 0. Call it as equation 5. So next what I will do? I will consider equation 3 and 5. Consider equation 3 and equation 5. Equation 3 can be written as AI plus B plus I will write that as 0C equal to 0. Equation 5 can be written as 0A plus B minus IC is equal to 0. Now I have two equations but with 3 unknowns. We can solve this by using the Cramer's rule. What is the Cramer's rule? So A by the determinant is equal to minus B. Variables we should write in the numerator. So major term should have a minus sign. A by determinant is equal to minus B by the determinant is equal to C by the determinant. What we should fill in the determinant? So closing this, don't consider A. So take the coefficients of B and C. That is 1, 0, 1, minus I. Next, so minus B by the determinant. Don't consider B coefficients. Take the coefficients of A and C. A, that is I. Coefficient of A is I. Then 0, and minus I. Here, don't take the C terms. Take the coefficient of A and B. I, 1, 0, and 1. This is I. Okay, now second order determinant we have to simplify. 1 into minus I is minus I minus 0 is equal to minus B by minus I into I square. I square is minus 1 minus 0 is equal to C by I minus 0. Therefore, A by minus I is equal to minus B by I square is minus 1 minus into minus plus 1 C by I. Okay, so if you want you can multiply with minus sign. So therefore, or you can keep as it is. A is equal to minus I, B is equal to minus 1 and C is equal to I. So the values of ABC. The values of ABC is A is minus I, B is minus 1 and C is I. Directly you can take. So now we got the values of A, B and C. So we should find the value of D. How to find the value of D? Where we can substitute either in equation 2 or in equation 4. If you substitute A, B and C, you can get the value of D. Okay. Now I am going to substitute in equation 2. So equation 2 become A is minus I plus B is minus 1 plus of minus 1 is minus 1 minus I into C is I minus ID is equal to 0. So what we got? So minus I minus, here I into I square is minus 1 Minus 1 means minus into minus plus 1. Plus 1 minus 1 cancelled. So what we got, minus I minus id equal to 0. I will go to the next page. Minus I minus id is equal to 0. Minus I minus id is equal to 0. I will take minus I common. 1 minus d, sorry, 1 plus d is equal to 0. Therefore, d is equal to d plus 1 is equal to 0. D is equal to minus 1 because minus I cannot be 0. So now we got the value for A, B, C, D. So what is A? What is A? A is minus I. What is B? B is minus 1 and C is I. So we have to substitute all these values in equation 1. What is our equation 1? W is equal to AZ plus B by CZ plus D. Now substitute. W is equal to, what is A? A is minus I Z plus B. B is what? Minus 1. Divide by C is I. C Z plus D. What is D? D is minus 1. So we obtain W is equal to minus IZ minus 1 divided by IZ minus 1. Take minus common in the numerator. It becomes 1 plus IZ. Take minus common in the denominator. It becomes 1 minus IZ. Minus minus cancel. Therefore, W is equal to 1 plus IZ by 1 minus IZ. This is the required transformation for the given points. So we can verify this. Verification we can do for our reference. Verification. How to do the verification? They are given three set of values of Z and W. What are the Z values given? Z is equal to 1, I minus 1 is given. If you substitute Z equal to 1, you should get the corresponding value of W. They are given as I 0 minus I. If you put Z is equal to 1, you should get W as I. If you put Z equal to I, you should get W as 0. If you put Z equal to minus 1, you should get W as minus I. I will check for 1 or 2 points. So put Z is equal to 1 in the equation 5. Equation 5 is the required solution for the given problem. Put, this is the verification I am doing. Put Z is equal to 1 in equation 5. So equation 5 become W is equal to 1 plus I, because Z is 1, by 1 minus I. Rationalize it and simplify. 1 plus I by 1 plus I. So that is 1 plus I into 1 plus I is 1 plus I whole square by A plus B into A minus B is A square minus B square. Numerator is A square plus B square plus 2AB. Divide by 1 square is 1, I square is minus 1. So that is 1, I square is minus 1 plus 2I by minus into minus plus 1 plus 1 is 2. Plus 1 minus 1 cancel, 2I by 2. 2 cancel I. So that is when Z is equal to 1, when Z is 1, W is equal to I. So that is the points in the Z plane will match the points in the W plane, 3 points. Points in the W plane. By the transformation, W is equal to AZ plus B by CZ plus D. So in this particular problem, 1 plus IZ by 1 minus IZ, that transforms the points 1 I minus 1 to I 0 minus I. That is from the points from Z plane to the points in the W plane. Right? Okay, next problem. Next problem. Find the bilinear transformation. Find the bilinear transformation. Find the bilinear transformation which map the points z is equal to 1 I minus 1 into w is equal to 2 I minus 2. Also find invariant points of the transformation. Also find invariance of the transformation. I will tell you what is the meaning of invariance of the transformation. Okay. First, I will find the bilinear transformation for the given set of points. The points given as z is equal to 1I minus 1 and w is equal to 2I minus 2. So consider the bilinear transformation. W is equal to az plus b by cz plus d. So that is equation number 1. Next, as I told you, we go for the case 1. In case 1, put z is equal to 1 and w equal to 2 in equation 1. So equation 1 become w is 2, 2 is equal to a is z is 1, that is a plus b by c plus d. Cross multiply 2 times c plus d is equal to a plus b. Take these two terms to the RHS, we get a plus b minus 2c minus 2d is equal to 0. Call it as equation number 2. Next, case 2, put z is equal to I and w is equal to I in equation 1. So equation 1 become w is I is equal to a into z is I plus b by c into z is I plus d. Therefore we obtain I into cross multiplication, I into IC plus D is equal to IA plus B. So take these two terms to the RHS, we obtain IA plus B minus I into I is I square is minus 1. If you take that to the RHS, it becomes plus 1 plus C minus ID is equal to 0. Call it as equation number 3. Next, case 3. What we have to put for z and w? Put z is equal to minus 1 and w is equal to minus 2 in equation 1. So equation 1 become w is minus 2 is equal to a into z is minus 1 plus b by c into z is minus 1 plus d. Now cross multiply, we obtain minus 2 into minus c plus d is equal to minus a plus b. So we obtain 2c minus 2d is equal to minus a plus b. Take these two to the RHS, minus a plus b minus 2c plus 2d is equal to 0. So that is equation number 4. See equation 2, 3 and 4. What simplification we can do is we can consider 2 and 4c. A and d will get cancelled. We will left with b and c, right? Okay. Consider equation 2 plus equation 4. What we will get? A plus b minus 2c minus 2d equal to 0 minus a plus b minus 2c plus 2d is equal to 0. So next, minus a plus a minus 2d plus 2d cancel. 2b minus 4c is equal to 0 or b minus 2c equal to 0. That is equation number 5. So next we have to get one more equation with bc. Okay, bc and one more variable. 3 variables only with the bc. Alright, and then what we can consider? So this we will see the equation 3 and equation 4. If we see equation 3 and equation 4, it become minus a. Then what we will get? So I will consider equation 2 plus I times equation 3. See what we will get. Equation 2 is what? A plus b minus 2c minus 2d equal to 0. Multiply equation 3 with I. Okay. Then what we will get? Sorry, equation 3 plus I times equation 4. So one minute. Consider equation 3 plus I into equation 4. What is equation 3? Equation 3 is here IA plus B plus C minus ID is equal to 0. Next multiply I with equation 4 minus IA plus IB minus 2IC plus 2ID is equal to 0. See, A and A cancel. We will left with B, C and D. Here we have B and C. Okay, one more constant extra, that is 2 equations, 3 unknowns. We can use Cramer's rule. Okay, it is 1 plus I into B. Next, C. This is 2IC, right? 2IC. This is 2IC. Okay, plus of 1 minus 2I into C plus of 2I minus I into D equal to 0. This is what we got, right? So next we have to consider the equations. I will call this as equation number 6. Next I will consider 5 and 6. I will consider equation 5 and equation 6. Consider equation 5 and equation 6. What is equation 5? B minus 2C plus 0D equal to 0. We can write the equation like this. Next equation 6 will be 1 plus I into B. Next plus 1 minus 2I into C plus, right, plus 2I minus I, 2I minus I, that is 2I minus I is I only, ID is equal to 0. So we got 2 equations with the 3 unknowns. Now we can easily use the Cramer's rule. We have to remember these 2 equations. B minus 2C plus 0D equal to 0. 1 plus I into B plus 1 minus 2I into C plus ID equal to 0. I will go to the next page. You have to remember that coefficients of B, C and D. Okay. So next what we have to consider? Cramer's rule. B by the determinant. We have B, C and D. Minus C by the determinant. For the middle variable we should take minus, equal to D by the determinant. Now not consider the coefficients of B, consider the coefficients of C and D from those 2 equations. So we would type minus 2, 0, 1 minus 2I and I. Okay, next minus C by the determinant. Don't consider the coefficient of C, consider the coefficient of B and D. 1, 0, 1 plus I and I. Next, don't consider the coefficient of D, consider the coefficient of B and C. So we obtained 1 minus 2, 1 plus I, 1 minus 2i. So now we have to simplify this. b by minus 2 into I is minus 2i, minus 0 into 1 minus 2i is 0, is equal to minus c by 1 into I is I, minus 0 is equal to d by 1 into 1 minus 2i is 1 minus 2i, minus of minus 2 is plus 2 into 1 plus I. Now simplification, b by minus 2i is equal to c by minus I. We can take that minus to the denominator. D by 1 minus 2i plus 2i plus 2 plus 2i. Plus 2i minus 2i cancelled. 1 plus 2 is 3. So that is b by minus 2i is equal to c by minus I is equal to d by 1 plus 2 is 3. Therefore, b is equal to minus 2i, c is equal to minus I and d equal to 3. So we have to find out the value of a. Substitute the values in equation 2. Okay, what is our equation 2? What is our equation 2? A plus b, because we have a in equation 2, 2 and 4, right? So either we have to substitute b, c, d in equation 2 or in equation 4. So I will put a b, c, d value in equation 2. Equation 2 is 2i plus b. Plus b. B is minus 2i plus c. What is c? Minus I minus di. Minus d is 3i is equal to 0. Now simplification, ai minus 3i minus I is minus 4i minus 4i minus 2i is minus 6i is equal to 0. So ai is equal to 6i. So a is equal to 6. Okay, we have to substitute a, b, c, d values in equation 1. So equation 1 become w is equal to az plus b by az plus b. What is b? B is minus 2i. Az plus b. W is equal to az plus b. Divide by cz. Cz plus d. Az plus b by cz plus d. So this is what we have. This is a transformation. Bilinear transformation which maps the points of Z to the points of W. So we have to find out the invariant points. What is the meaning of invariant points? Invariant points is nothing but a fixed point. It is not changing if you transform the point in Z plane to the point in the W plane. Therefore, we can put W is equal to Z. So to find invariant points, put W is equal to Z in equation 6. I will call this as equation number 6. So we obtain Z is equal to 6Z minus 2I divided by minus IZ plus 3. Now cross multiply Z into minus IZ plus 3 is equal to 6Z minus 2I minus I Z square plus 3Z minus 6Z plus 2I is equal to 0. So next minus IZ square minus 3Z plus 2I is equal to 0. So we have to find out the Z values. Okay, we have to solve this quadratic equation for Z. Factorization is not possible. We have to go for the formula method. Z is equal to minus b, minus of minus 3 minus b plus or minus square root of b square minus 4ac minus 4ac by 2a. 2a is minus I. Now simplification, z is equal to 3 plus or minus square root of 9 minus 8i, right? Minus c is 2i says 2i, I into I square. I square is minus 1, minus into minus plus into minus minus, 4 to some 8. 8, 9 minus 8 by minus 2i, right? So that is 3 plus or minus root 1 is 1 itself by minus 2i. Or z is equal to 3 by minus 2i plus or minus 1 by minus 2i. These are points what we got. Or we can write this as 3 plus or minus 1, right? Okay. I will write this as z is equal to 3 plus 1, 4. 4 by minus 2i, or 3 minus 1, 2. 2 by minus 2i. So 2 2s are 4. 2 2s. If you take I to the numerator, it becomes minus I. So minus minus cancel. So answer is 2i. Okay, and here 2 and 2 cancel, take I to the numerator, it become minus I, minus and minus cancel, therefore z is equal to I. So z is equal to 2i and z equal to I are the invariant points for the given transformation.